we're looking at the idea of stable equilibrium and unstable equilibrium at one go with one video. So let me show the video, that will be easier for me to discuss. So we have mirror. Okay. So one is a concave mirror and another is convex mirror. So you guys have to decide which is concave, which is convex. So you guys will get to know that actually. And also decide on which is stable equilibrium and which is unstable equilibrium. So which is concave, which is convex? Yes, the left one is concave, it's caved in. This is convex. So basically, let me move to this. So if I take the cross section of concave, this is what we're looking at. Okay, cross section. I remember this is a cross section. So if I happen to, which I am actually, if I am leaving a ball bearing over here, it comes back, it stays over here, somewhere over here. While you're convex, and if I happen to leave a ball bearing over here, it's running away. So which is stable and which is unstable? Yes, this is stable equilibrium. This is unstable equilibrium. So please understand that we're looking at small displacement. So let me read through. After a small disturbance or a displacement, a slight tilt or a push, the body returns to its original position due to a restoring force or a torque that opposes the displacement. So in terms of potential energy, at a local minima, small deviation increases the potential energy, creating a restoring effect. So let me explain this. So this is our topic for the next chapter actually. This has potential energy which is A, and this has potential energy which is B. The gravitational potential energy at A is lesser than gravitational potential energy at B. I think that you guys can understand, right? I mean, it's not a big deal. Gravitational potential energy at A and gravitational potential energy B, or let me just write it as A and B. This is point A and point B. So this is to do with gravitational potential energy. Gravitational potential energy. So you guys have studied potential energy. Now we're looking at the idea of gravity. So basically, the object has, I mean, if you guys know it, if I leave anything at the top, it will come to the least potential energy place, right? And that's in nature. You guys see this every day. So any small displacement, the ball bearing will come back. That's what the statement tells, right? So that's what we saw in the video also. Any small displacement will come back. Of course, there's a lot of other factors over here. I'm not going to the detail, but somewhere around here is your lower potential energy. So at a local minima, the small deviation increases the potential energy, right? So if I happen to push the object from point A to point B, it increases the potential energy. Thus, because there is an increase and there is a way to go to the lower potential energy, the ball bearing comes back. A ball resting in the bottom of a concave ball, if displaced slightly, gravity restores it to the center. That we just saw with concave. Real world application, a chain on a level ground. Minor rocking raises the center of gravity, promoting it to settle back evenly. So let me explain. Actually, there's nothing to explain. You guys can write this example itself. While you are unstable equilibrium, as in definition, a small disturbance causes the body to depart further from its original position. That makes sense, right? If I push it a bit, it'll go running. By chance, if I am able to keep it on the top and it's sitting over there, a small push and it will destabilize it. So basically, if we talk about the gravitational potential energy over here, the gravitational potential energy at A is greater than B. Okay, so a small push will make it run away. Right, and finally you have neutral equilibrium. So for that I have this for you guys. Right, so that is at equilibrium. Now I'm trying to displace it by a small distance. So you can see what's happening. I'm trying to do it for a small distance. So you can see it is stable over there. So basically in your neutral equilibrium, the thing is, if you have a small displacement, unlike your other two, small displacement was a big deal. So if here in this case, if I happen to displace it by a small distance, say it is over here, I displace it and I keep it over there or push it over there, it stays there. A small push again, it will stay there. If a small push again, it will stay there. A small push again, it will stay there. A small push again, it will stay there. So basically, point A and point B, the gravitational potential energy at point A is same as gravitational potential energy at point B. That's the whole funda, right? So that's that. A ball on a perfectly flat horizontal surface, rolling it to a new location leaves it equally balanced. Right, guys? So these are your classifications. Oh, yeah, sorry, I should show you guys the diagram. And now you can start with unstable.